This tutorial is all about atom economy. Atom economy is a measure of how many of the atoms of the reactants actually end up as atoms of useful product. This is the specification content to understand that atom economy is a way of measuring the amount of atoms that are wasted when manufacturing a chemical, because 100% atom economy means that all the atoms in the reactants end up in the products. And industry wants high atom economy because that means it's a greener process and less of the reactants are wasted. Some products can be made in a variety of different ways, and the role of the chemical engineer is to find the most efficient way of doing a chemical process. Taking as an example magnesium sulfate, which is a metal salt, it can be made in 4 different ways. The first method might involve using the metal magnesium and reacting that with sulfuric acid. You'd use an excess of magnesium, react it with the sulfuric acid to make a mixture of magnesium sulfate solution and the remaining magnesium, filter off the remaining magnesium to just leave you a solution of magnesium sulfate, and then use that to concentrate up and make crystals of magnesium sulfate. A second way is to use an insoluble base, magnesium oxide, with sulfuric acid, again adding an excess of magnesium oxide into the heated acid. That leaves you a mixture of magnesium sulfate solution with the excess magnesium oxide, which again has to be filtered off, and you end up with the magnesium sulfate solution, which can then be concentrated up to make crystals. A third method uses magnesium hydroxide and another base reacting with sulfuric acid, using largely the same method as method 2. And method 4 might use magnesium carbonate to neutralize the sulfuric acid. This, when it's added to the acid, would make bubbles of carbon dioxide and a solution of magnesium sulfate, which then would be filtered away from the excess magnesium carbonate to again give you magnesium sulfate solution to concentrate up and make some crystals. So how do we decide which of the 4 methods is the best? One way of comparing the efficiency of the method is to look at how much of the product is made compared with how much of waste product is made. In each case we're making 120 grams of magnesium sulfate, but the quantities of the other product, the waste product being made, varies in each case. So which one at first sight seems the least wasteful method, and why? One way of showing which is the most efficient or least efficient method mathematically is to use something called atom economy. You need to learn this equation for your exam because it's not given on your paper. The atom economy is the relative formula mass of the desired product divided by the sum of the relative formula masses of all of the products expressed as a percentage. And you need to be able to calculate that atom economy when you're given a balanced symbol equation and various relative formula masses. Percentage atom economy is important because nowadays all industry wants to be green. It wants to make chemical products but doesn't want to make waste. So the method that they can make their product but leaving the least mass of waste has to be the best. And that's why industry looks at atom economy, and 100% atom economy means that all the atoms in the starting materials have been converted into the product. This is rare, but it's not entirely uncommon. But in most cases, there's a high atom economy, but it's rarely 100%. Looking at each of those 4 methods of making magnesium sulfate again, we can see that the best method is method 1, because out of the 122 grams in total of products, 120 grams of that 122 is your actual product magnesium sulfate, and only 2 grams is wasted. The worst method, really, looking at it from a green point of view, is method 4, because here 120 grams of magnesium sulfate are made, but 18 plus 44 or 62 grams of wasted product are made. If we were to calculate the atom economy of method 1, we would say that the atom economy equals the mass of the useful product, 120 grams, divided by the total mass of the products, which will be 122 grams, times 100%, and 120 divided by 122 times 100% would be 98.4%, which is a very high atom economy. So the equation is that the atom economy equals the relative formula mass of the desired products divided by the sum of the relative formula masses of all of the products expressed as a percentage. Again, I stress you must learn that equation. Here's another process. In the blast furnace, iron is made using this equation. So what's the percentage atom economy here? You might want to pause the presentation while you do the calculation and show you the answer on the next slide. So to do this question, we need to refer back to the original equation, which was that atom economy is the MR of the desired products divided by the sum of the MR of all the products expressed as a percentage by multiplying by 100. Now, in this case, the desired product is Fe, and the mass of the two Fe atoms is 2 times the relative atomic mass of iron, which is from the periodic table 56, which is 2 56s, which is 112. So the numerator on here will be 112. Then we have to work out the mass of all the products, and that will be the 2 iron atoms, which is 2 56s, 112, plus 3 carbon atoms, that's 3 12s, 36, plus 3 times 2, which is 6 oxygen atoms, that's 6 16s, which are 96. Add them together, it makes 244, so the denominator is 244. Therefore, the atom economy is the 112 divided by 244 times 100%, and that comes out to 45.9%. This means that just less than half of the products are useful, and the remainder, the carbon dioxide, makes up more than 50% of the mass and is wasted.